What if I told you that every atom in your body, right now, in this moment, came from inside a star? Your calcium came from a star. Your iron came from a star. Even the oxygen you're breathing as you watch this? A star made that too. But here's what will blow your mind. The star that created the atoms in your body exploded billions of years ago. You're not just watching a video about the galaxy. You're watching a story about your own existence written in starlight. Before we go any further, I need you to do 3 things. First, hit that subscribe button right now, not later, now. You're about to have your entire understanding of the universe changed. Second, smash that like button. Third, drop a comment and tell me, what country are you watching from? And what time is it where you are? I read every single comment, and I want to know who's on this cosmic journey with me. Are you in Tokyo? London? Snow Hollow? Let me know. Now, you've probably looked up at the night sky and thought, those are just twinkly lights. But you're completely wrong. And I mean that in the most fascinating way possible. What you're looking at isn't decoration. It's a crime scene. It's a nursery. It's a graveyard. It's a love story written in nuclear fusion. And today, I'm taking you through all of it. Here's the challenge I want to give you. By the end of this video, you won't be able to look at the night sky the same way again. Your brain won't let you. The universe is going to feel more real, more violent, more beautiful, and more personal than ever before. For 3 centuries, we've been gathering evidence about what stars actually are. And the scientists who did this work, they weren't just writing equations in notebooks. They were unraveling the most profound mystery of existence. Why are we here? What is our place in the cosmos? Where did we come from? Think about it like this. Imagine if I told you that the water you drink, the metal in your phone, the calcium in your bones, they all contain a message from the past. A message written in atomic structure, waiting to be decoded. That's what stars are. They're messages from the universe about how you came to exist. By understanding the stars, we don't just understand the night sky. We understand ourselves. We understand why we're made of stardust, why our bodies are cosmic in origin, and why the universe went to such extraordinary trouble to create beings capable of looking back up at it and asking questions. So if you're ready to have your worldview fundamentally restructured, if you're ready to feel the weight of cosmic significance settle on your shoulders, then keep watching. And remember, you already promised you'd hit subscribe. Let's go. Okay, let's start with something that seems simple, but is actually the weirdest thing in the universe. What is a star? Your first instinct is probably, it's a hot ball of gas in space. You're not wrong, but you're also massively underselling it. Let me flip your understanding. A star isn't just hot. A star is a nuclear bomb that's been detonating continuously for billions of years, and it hasn't destroyed itself. Think about that. We built nuclear weapons that are designed to explode once. Stars have been exploding from their very core, continuously, for longer than life has existed on Earth. And instead of destroying themselves, they're held together by their own gravity. This is the first mind-blown moment. Gravity is actually a cage. A star is a prison where atoms are forced so close together, squeezed with such unimaginable pressure, that the nuclei of atoms begin fusing together. When hydrogen nuclei fuse, they create helium, and that fusion releases energy. Enormous amounts of energy. The energy that hits your face when you stand in sunlight comes from this process happening 386 billion times per second inside the sun. Let's ground this in something real. The sun is so far away that light takes 8 minutes to reach us. In that 8 minutes, an incomprehensible amount of energy travels through empty space and hits Earth. On a clear day, about 1,360 watts of solar energy hit every square meter of Earth's surface. That's equivalent to a powerful space heater. And that's just the energy that makes it to us. The sun is actually sending that energy in all directions simultaneously. Do you understand the scale of what we're talking about? In 1920, an astrophysicist named Arthur Eddington made a controversial discovery. He proposed that stars generate energy through nuclear fusion. At the time, we didn't fully understand nuclear physics yet, but Eddington used experimental evidence and mathematical models to demonstrate that the only way stars could stay hot for billions of years was if they were converting mass into energy. In 1938, Hans Bethe, a physicist who later won the Nobel Prize in 1967, discovered this specific mechanism. He mapped out the carbon-nitrogen-oxygen cycle and the proton-proton chain reaction, showing exactly how hydrogen atoms fuse into helium inside stars. This was revolutionary, because it meant we could finally answer a question humanity had asked for thousands of years. How do stars shine? The answer is controlled thermonuclear fusion. But here's where it gets really interesting, and why you need to keep watching. Different stars fuse hydrogen in slightly different ways, depending on their temperature and mass. And that difference, that tiny variation, determines everything about what the star becomes, how long it lives, whether it dies peacefully or violently, whether its death creates new worlds or tears apart everything nearby. Think of it like this. Imagine if the blueprint for your entire life was determined by your birth weight. A tiny difference in how heavy you were at birth would change everything: how tall you'd grow, how long you'd live, what diseases you'd be susceptible to. Stars work the same way. A star 20% more massive than the Sun will live a wildly different story. A star 20% less massive gets a completely different fate. Let me make this tangible. The Sun, our Sun, is actively converting 600 million tons of hydrogen into helium every single second. That's more mass converted to energy in 1 second than humanity has ever created in chemical explosions. And it's doing this gently, peacefully, in a perfect balance. The outward pressure from fusion is exactly balanced by the inward pressure from gravity. It's a cosmic equilibrium. But this equilibrium won't last forever. The Sun has been burning hydrogen for about 4.6 billion years. We have maybe 5 billion years left before the hydrogen runs out. And when it does, well, that's a story for another section. By the way, if you're still here, you already know more about stellar fusion than most people on Earth. Congratulations. But stick around, because we're about to get into the really weird stuff. The things that even make cosmologists say, wait, how is that possible? Let me ask you this before we move on. Do you think the Sun will ever run out of fuel? Or do you think it'll burn forever? Comment your guess below, and I'll come back to this question in just a few minutes. Here's what we know so far. Stars are nuclear furnaces held together by gravity. Hydrogen fuses into helium. This releases energy. That energy spreads out in all directions. Some of it hits Earth and warms your face. But now, we need to ask a deeper question. What happens when a star gets bigger? What if a star is twice the Sun's mass? What if it's 10 times bigger? Because that's where things get wild. That's where stars stop being peaceful and start being catastrophic. And to understand that, we need to talk about something that most people completely misunderstand: the relationship between mass and lifetime. You'd think that a more massive star would burn longer, right? More fuel, more time. But you'd be completely wrong. And when I explain why, it's going to reframe everything you thought about how the universe works. Keep watching. What if I told you that the most massive stars in the galaxy actually live the shortest lives? A star that's 20 times the Sun's mass will die before the Sun even gets close to dying. How is that possible? How can more stuff lead to less time? This is counterintuitive. This violates our everyday intuition, but it's true, and it's beautiful, and it shows us something fundamental about how the universe works. Here's the mechanism, and I want you to really absorb this because it changes everything. A more massive star experiences greater gravitational pressure at its core. That crushing pressure from all that mass pushing down creates higher temperatures. Higher temperatures mean the hydrogen nuclei move faster, collide more frequently, and fuse more rapidly. The star burns through its fuel faster, much faster. Think of it like this. Imagine you have two cars with the same size fuel tank. One car's engine is tuned to run at 10,000 RPM constantly. The other runs at 2,000 RPM. Which one runs out of fuel first? The high-revving engine, obviously. Massive stars are the same way. They're cosmic V16 engines burning through hydrogen at a frantic pace. Here's the mathematical relationship, and this is beautiful. The lifetime of a star is roughly proportional to its mass, divided by its luminosity to the 2.5 power. This is called the mass-lifetime relationship. A star with 10 times the Sun's mass might live only about 10 million years. Our Sun, with one solar mass, lives about 10 billion years. That's 1,000 times longer. In 1924, Arthur Eddington developed this understanding further. He showed mathematically that massive stars must burn hotter and faster. But it wasn't until 1926 that Cecilia Payne-Gaposchkin, a female astronomer working at Harvard Observatory during an era of profound gender discrimination, made a discovery that confirmed this. She analyzed the spectra of thousands of stars and demonstrated that the Sun is actually fairly average. Most massive stars indeed burn hot and die young. Payne-Gaposchkin wasn't just discovering this. She was revolutionizing our understanding of stellar composition and lifetimes. Her work was so significant that it's considered the most important PhD thesis in the history of astronomy. And yet, she was paid barely anything, and her male colleagues initially tried to take credit for her discoveries. This matters to you because it explains something profound. The universe creates diversity on purpose. If all stars lived the same amount of time, if massive stars burned as long as small ones, the galaxy would be a monotonous place. But instead, the universe has engineered a system where massive stars burn bright and fast, living only millions of years. Meanwhile, small red dwarf stars can burn for hundreds of billions of years, far longer than the current age of the universe. This creates a cosmic cycle. Massive stars explode quickly, seed space with new elements, and die. That creates conditions for smaller, longer-lived stars, which create the environments for planets, which create the conditions for life. And here's what will blow your mind even more. The most massive stars that ever existed, the ones at the very beginning of the universe, they're all dead now. Every single one of them. They burned so fast that they exhausted their fuel while the universe was still a baby. But when they died, they created elements that the Sun is made of. This is the cascade effect. One generation of stars creates the building blocks for the next generation. But we're getting ahead of ourselves. We need to understand what happens when a star dies, because that's where things get absolutely cosmic. So we have this incredible system. Massive stars burn bright and fast, creating elements. Now, the question is, what happens when a massive star runs out of hydrogen? Does it just turn off? Does it go dark? No, that's the thing nobody tells you. When a massive star runs out of hydrogen, it doesn't die. It enters a panic state, and that's where the story gets really interesting. Imagine you're a star. You're massive. You've been burning hydrogen, and suddenly, you detect something catastrophic. Your fuel is running out. What do? Well, if you're a star, you have a fail-safe system. You have a backup plan. You start fusing something else. This is what blows people's minds. Stars don't just burn hydrogen. They burn progressively heavier and heavier elements in stages, like a multi-stage rocket. A massive star's core becomes like an onion. The innermost layer is fusing iron. The next layer out is fusing silicon, then sulfur, then neon, then oxygen, then carbon, then helium, and the outermost layer is still burning hydrogen. Think of it like this. Imagine a building where the basement is an inferno, the ground floor is burning, the second floor is on fire, but in a controlled way. The third floor is just getting warm, and the top floor is cool and peaceful, all happening simultaneously. That's a massive star in its final stages. Each of these fusion stages creates progressively heavier elements. Hydrogen fuses into helium. Helium fuses into carbon and oxygen. Carbon and oxygen fuse into neon. Neon fuses into magnesium. This continues all the way up to iron. In the 1950s, Margaret Burbidge, Jeffrey Burbidge, William Fowler, and Fred Hoyle worked together to create what's now called the B2FH paper, published in 1957 in Reviews of Modern Physics. This paper, which Fowler won the Nobel Prize for in 1983, showed exactly how stars create every element in the periodic table except the lightest few. They demonstrated that iron is the endpoint. A star cannot fuse iron. The moment a star starts fusing iron, it has signed its own death warrant. Here's why. Fusion only releases energy up to iron. Iron is the most stable element. When you try to fuse iron nuclei together, you don't get energy released. You have to put energy in. It's like pushing a boulder uphill. At that moment, the star's core is no longer producing outward pressure to balance gravity. And gravity wins. The collapse happens in seconds. Not minutes. Not hours. Seconds. A massive star's core, which might be the size of Earth, collapses from that size to the size of a city, then the size of a mountain, then the size of a building, then the size of a marble, all in less than a second. Do you understand what this means? This means that the iron in your blood, the iron that's right now bound up in your hemoglobin molecules, carrying oxygen through your arteries, was created in the dying moments of a massive star's life. Your blood literally contains stellar collapse. When a star collapses, the electrons and protons are crushed together so hard that they fuse into neutrons. The density becomes incomprehensible. A teaspoon of neutron star material would weigh as much as Mount Everest. We're talking about a density that has no analog in human experience. But here's where it gets even more insane. When that collapse happens, the star bounces back. The infalling material hits something incompressibly dense in the core and rebounds. It's like dropping a steel ball from the top of a building onto a diamond floor. The ball rebounds with tremendous force. In a star, that rebound is traveling at speeds of 30,000 kilometers per second. A shock wave tears through the star's outer layers. That shock wave hits the iron core, passes through it, and emerges on the other side. And when it does, it tears the star completely apart. An explosion so powerful that it outshines an entire galaxy of billions of stars combined. This is a supernova, and it's the most powerful single event in the universe. The explosion takes place over seconds, but it releases more energy than the sun will release in its entire 10 billion year lifetime. Let me say that again. One supernova explosion releases more energy than our star will release in 10 billion years. When this explosion occurs, it tears apart the star. But it also does something else. It creates new elements. Elements heavier than iron. Cobalt, nickel, copper, zinc, silver, gold. Every precious metal in your jewelry, every heavy element in your body, they were all created in the death throes of a massive star. But that's not even the most incredible part. When a supernova explodes, it doesn't just dissipate into space. It seeds the galaxy with elements. It sends shockwaves that compress nearby clouds of gas and dust. And those compressed clouds begin to collapse under their own gravity. They begin to form new stars. A supernova is the universe's way of saying, we're not done here. Think about the stakes. A star has been burning peacefully for millions of years. Then, in a single moment, it explodes. The explosion is so bright that for a few days, it can outshine an entire galaxy. But more than that, the explosion transforms everything. Here's what will blow your mind. Without supernova, you don't exist. And not in a poetic sense, in a literal, chemical, atomic sense. Let me explain. The Big Bang created hydrogen and helium. That's it. Carbon, nitrogen, oxygen, iron, silver, gold, uranium, none of those existed at the beginning. Every single atom of every element heavier than helium that currently exists in the universe was created inside a star. And every atom of every element heavier than iron was created in a supernova explosion. Your body is mostly carbon, hydrogen, oxygen, and nitrogen. Your carbon was made in a star and scattered by a supernova. Your oxygen was made in a star and scattered by a supernova. Your iron was made in a star and scattered by a supernova. You are not just made of stardust. You are made of supernova shrapnel. In 1987, something extraordinary happened. A massive star in the Large Magellanic Cloud, a small galaxy about 160,000 light-years away, exploded. Astronomers call it supernova 1987A. For the first time in human history, we had the technology to observe a supernova in real time with modern instruments. Astrophysicists like Stan Woosley and Tom Weaver used supercomputer models to simulate the explosion. They watched in real time as a shock wave tore through the star's iron core, as it blasted outward as it heated the surrounding material. Their predictions matched observations almost perfectly. These simulations showed us exactly which nuclear reactions occur during a supernova explosion, confirming that heavy elements are indeed created in these violent events. Let me make this real for you. Right now, scientists are monitoring the remnants of supernova 1987A. They can actually see the expanding shell of material from the explosion. The material is still moving at 30,000 kilometers per second, so fast that you could travel from Earth to the Moon in just 12 seconds at that speed. The explosion released as much energy as the Sun will release in its entire 10 billion-year lifetime, concentrated into the energy released in about 10 seconds. Think of it like this. The Sun is like a car driving at a constant speed for billions of years. A supernova is like a nuclear bomb. One has incomprehensibly more power than the other, released in an incomprehensibly shorter time frame. But here's the thing. The explosion doesn't just release energy. It creates new elements, and those elements get scattered into space. When a supernova explodes, it sends shrapnel into the interstellar medium at incredible speeds. That shrapnel is enriched with heavy elements: iron, nickel, cobalt, copper, zinc, silver, gold. This enriched material begins to slow down. It collides with nearby clouds of gas and dust. And here's where the cascade effect really kicks in. The collision creates shock waves that compress those clouds. The compression causes the clouds to begin collapsing under their own gravity. And when a cloud of gas and dust collapses, a new star is born. But not just one star, hundreds, thousands. An entire stellar nursery emerges from the ashes of a single dead star. And this isn't just philosophical. This is measurable. We've actually observed supernova remnants that are still triggering star formation today, millions of years after the explosion occurred. This is the cosmic cycle. This is how the universe renews itself. Think about the implications. A massive star is born. It lives for a few million years. It dies in a supernova explosion. That explosion creates heavy elements. Those elements are scattered into space. They compress nearby gas clouds. Those clouds form new stars. Some of those new stars are surrounded by planets. On some of those planets, chemistry begins to happen. Organic compounds form. Life emerges. Without supernova, without those violent cosmic cataclysms, life would not exist anywhere in the universe. So when you look at the night sky, you're not looking at peaceful lights. You're looking at the evidence of a process of creation and destruction that literally made you possible. Imagine a cloud so massive that it contains the mass of 1,000,000 suns. A cloud so cold that it's only 10 degrees above absolute zero. A cloud so dark that light cannot pass through it. And inside this cloud, something miraculous is happening. Gravity is weaving stars together like a cosmic loom. This is a stellar nursery, and they're some of the most beautiful objects in the universe. Here's what will blow your mind. We cannot see most of a stellar nursery with visible light. A stellar nursery is so thick, so packed with dust, that visible light cannot penetrate it. If you looked at the Orion Nebula with your eyes, you'd see mostly empty space. But if you look at it with infrared telescopes, you see an explosion of newborn stars, still surrounded by the gas and dust from which they formed. This tells us something profound. The universe hides its greatest treasures behind veils. The nurseries where stars are born are invisible to optical telescopes. They're only revealed through infrared, radio, and other wavelengths. Think of it like this. Imagine if forests could only be seen through special glasses. Imagine if you had to wear infrared goggles to see where life is being created on Earth. That's what stellar nurseries are like. We developed infrared telescopes, and suddenly, the universe revealed an entire hidden landscape of star birth. In the 1990s, the Hubble Space Telescope began observing stellar nurseries. Astronomer Jeff Hester and his colleagues used Hubble to photograph what's called the pillars of creation in the Eagle Nebula. These are towering columns of gas and dust, a few light years tall, where stars are actively being born right now, in real time. The most famous image was taken in 1995. In this image, you can see evaporation fronts, the surfaces of these gas pillars, being eroded away by ultraviolet radiation from nearby newborn stars. The pillars are being destroyed, but in the process, they're creating the conditions for new star formation. It's creative destruction on a cosmic scale. But here's what makes this even more profound. When Hubble took another image of the same region in 2014, the pillars had changed. They had been eroded visibly in just 19 years. This means we're watching star birth in real time. Not in cosmic time scales of millions of years, but in human time scales. In your lifetime, the shape of these stellar nurseries will change. Think about what this means. When you look at the pillars of creation, you're looking at stars that haven't even finished forming yet. You're looking at objects that are younger than most human civilizations. Some of those newborn stars might have planets around them right now. On some of those planets, in millions of years, life could emerge. You're looking at potential futures. You're looking at worlds that don't exist yet, being created before your eyes. The formation process itself is incredible. A molecular cloud begins to collapse. As it collapses, it heats up, but the heating is uneven. Some regions are denser than others. Those denser regions collapse faster. They form clumps. Those clumps fragment further into smaller clumps. Eventually, some clumps become dense enough and hot enough that hydrogen fusion ignites. A star is born. But here's something amazing. Most stars don't form alone. They form in clusters. Sometimes in clusters of hundreds or thousands of stars, all born from the same gas cloud, all around the same time. The Pleiades cluster, which you can see with your naked eye on a clear night, contains about 1,000 stars. They were all born from the same gas cloud about 100 million years ago. Can you imagine? 1,000 suns born together, all dancing through space together? And we can see them with our naked eyes from Earth? If you haven't already, please go outside on a clear night and look at the Pleiades. Or look up the Hubble image of the pillars of creation. See the universe being born. Share it in the comments. Tell me which constellation you looked at. Tell me what you felt when you realized you were looking at a nursery where stars are being born right now. Now, here's the crucial question. When stars form in these nurseries, they don't form alone. Something else forms with them. And this is where things get even more personal, because it's where your story really begins. Around newborn stars, something remarkable happens. The gas and dust that didn't become part of the star settles into a disk. This disk begins to spin. And inside this disk, grains of dust collide and stick together, The grains become pebbles. The pebbles become rocks. The rocks become planets. This is the formation of planetary systems. And the raw material for planets? It's created from supernova explosions. For billions of years, we thought Earth was unique. We thought the sun was special because it had planets. We thought we were alone in that regard. Then we discovered we were completely wrong. In 1995, astronomers detected the first exoplanet, a planet around another star. It orbited a star called 51 Pegasi, which is only 47 light-years away, right next to us in cosmic terms. The detection was made by Michel Mayor and Didier Queloz, using a technique that measured the tiny wobble a planet's gravity induces in its star. This discovery changed everything, because it meant planets weren't rare. They weren't unique to our solar system. They were normal. Stars had planets. Lots of them. Here's what will blow your mind. We now know of over 5,500 exoplanets. And in almost every case, we can tell you about the planet without ever seeing it directly. We can know its mass, its orbital period, its temperature, its atmospheric composition. We know these things because the universe leaves signatures. Stars dimly when planets pass in front of them. Stars wobble when planets orbit them. These signals reach us across light years, and we can decode them. The Kepler Space Telescope, which operated from 2009 to 2018, discovered over 2,600 exoplanets. It did this by staring at about 150,000 stars continuously and measuring the tiny dips in brightness when planets crossed in front of their stars. The precision required was incredible. Kepler had to detect brightness changes of just 0.01%. That's like detecting the flicker of a flashlight on the moon from Earth. The mission was led by scientists like William Boretsky and John Jenkins, who developed the algorithms to distinguish real planet signals from noise. Their work showed that planets are ubiquitous. Almost every star has at least one planet. Think about that. When you look up at the night sky and see a star, you're looking at a star that almost certainly has planets. And statistically, some of those planets are likely to be Earth-like, habitable, possibly even inhabited. We estimate that there are more planets in the universe than there are grains of sand on all of Earth's beaches. Let that sink in. More planets than grains of sand on Earth. And we've only discovered about 5,500 of them. We're finding new ones every week. Here's something to make this tangible. An Earth-like planet in a habitable zone where water could exist in liquid form is orbiting a star about 12 light-years away, called Tau Ceti. We haven't directly imaged it yet, but we know it's probably there based on the gravity patterns we've detected. Tau Ceti has at least 5 planets in orbit around it. 12 light-years is a cosmically short distance. If we could travel at 1% the speed of light, which is a technology we don't have yet, but it's theoretically possible, we could reach Tau Ceti in 1,200 years. Your descendants, if they live that long, might colonize that system, might walk on one of those planets. But here's the really profound part. All of these planets, every single one of them, is made from the remnants of stellar evolution. Every rocky planet contains iron from a supernova. Every atmosphere contains carbon from a red giant star. Every drop of water contains oxygen from a star that lived and died billions of years ago. You're not looking at foreign worlds. You're looking at worlds made from the same cosmic material that made you. Let me ask you to imagine something. On one of these exoplanets, there might be organisms looking up at their star, wondering if life exists elsewhere in the universe. They might be intelligent. They might have built civilizations. They might be looking up at their night sky and asking the same questions you're asking right now. You are not unique in wondering if you're alone. Billions of beings on billions of planets might be asking the same question simultaneously. Right now. This instant. That's the implication of what we've discovered. Life is probably not rare. Given the number of planets and the chemistry of the universe, life might be common. Intelligent life might exist on millions of worlds, and we might be on the verge of detecting it. Now, here's the question that leads to the next mind-bending concept. If planets are so common, if life might be common, where is everybody? Where are the aliens? This is called the Fermi paradox. In 1950, physicist Enrico Fermi asked, "Where is everybody? We have billions of galaxies, with billions of stars in each galaxy. The probability of life emerging should be extremely high. So why haven't we detected any extraterrestrial civilizations? Why is space so quiet?" The answer involves the life cycle of stars and the vulnerability of planetary systems to cosmic catastrophes. What if I told you that stars are slowly destroying the worlds around them? What if every planet orbiting a star is on a countdown timer to destruction? This is the reality, and it changes everything about how we should think about life in the universe. Here's something most people don't realize. When a star dies, it doesn't die quietly. When a star like our sun dies, it becomes a red giant. The star's outer layers expand. They swell outward. The sun will expand so much that it will engulf Mercury, Venus, and possibly Earth. Let me be absolutely clear. The sun is going to kill our planet, not in billions of years if we're unlucky. In 5 to 7 billion years, guaranteed. It's not a threat, it's a certainty. It's written in the physics of stellar evolution, but that's not even the worst part. After a star like the sun expands into a red giant, it eventually sheds its outer layers. These layers are expelled into space at speeds of thousands of kilometers per second. The layers form a beautiful, expanding shell of gas and plasma called a planetary nebula. Meanwhile, the star's core collapses. It becomes a white dwarf. A white dwarf is incomprehensibly dense. It's a stellar core squeezed down to the size of Earth, but it contains the mass of the entire original sun. A teaspoon of white dwarf material would weigh as much as an elephant. The density is so extreme that atoms themselves are compressed. Electrons are forced into the nuclei, creating neutron-rich material. Think of it like this. Imagine if you took all the material in the Rocky Mountains and compressed it into the size of a marble. That's the density of a white dwarf. In 1914, Arthur Eddington made a discovery that almost broke physics. He was observing a star called Sirius B, the companion to Sirius A. He calculated its mass using orbital mechanics, observing how it orbited its companion. Then he calculated its volume based on its brightness. When he compared mass to volume, the result was so absurd that Eddington famously said, "Either you have found a piece of the stars themselves, or your reasoning is faulty." He wasn't being poetic. He was saying the result was physically impossible. Sirius B's density seemed to violate everything physicists understood about matter. It wasn't until the 1930s, when quantum mechanics matured, that physicists realized white dwarfs were supported by electron degeneracy pressure, a quantum mechanical effect where electrons resist being squeezed together. Now, here's where this affects you. When the sun becomes a white dwarf, if any planets survive the expansion phase, they'll orbit this incredibly dense remnant. A planet orbiting a white dwarf would experience tidal heating. The planet would be pulled and stretched by the white dwarf's gravity. Over millions of years, this tidal heating would likely render the planet completely lifeless. But for massive stars, it's even worse. Massive stars don't become white dwarfs. They become neutron stars. A neutron star is so dense that a teaspoon of its material would weigh as much as Mount Everest. A neutron star is about 20 kilometers in diameter, yet it contains the mass of the entire sun, and the most massive stars don't even become neutron stars. They become black holes. A black hole is where gravity is won so completely that not even light can escape. The star collapses to a single point of infinite density called a singularity. Surrounding this singularity is an event horizon, a boundary beyond which nothing can escape. Think of it like this. A black hole is what happens when gravity becomes the only force that matters. when gravity doesn't just win, it takes everything. Now, imagine you're a planet orbiting a massive star. You've been orbiting peacefully for a few million years. Then your star explodes in a supernova. The star is gone. A black hole remains. The explosion has probably destroyed you. But if it hasn't, you're now in orbit around a black hole, in a hostile region of space filled with the remnants of the explosion. Life doesn't stand a chance. This tells us something. Planetary systems are not stable over the long term. They're fragile. They're vulnerable. A star's violent death can sterilize an entire system. It can erase billions of years of biological evolution in a single cataclysmic moment. This is part of the answer to Fermi's question. Where is everybody? Maybe civilizations are created, but stellar death destroys them. Maybe intelligent life is rare, not because it's hard to create, but because it's hard to maintain. Because stars are mortal. Because everything around them is doomed. But wait, let me complicate this further. Because there's another factor we haven't discussed. Another way that stars destroy the planets around them while they're still alive. Stars emit something more than just light and heat. They emit a constant stream of charged particles called the solar wind. For Earth, the solar wind is mostly harmless. We have a magnetic field that deflects it. But not all planets have magnetic fields. And some stars emit solar winds that are far more intense than the sun's. Some stars emit stellar flares so powerful that they strip the atmospheres away from planets. They erase the conditions for life in an instant. A single stellar flare from some types of stars can release as much energy as the sun releases in a year. This process is called atmospheric escape, and it's another way that the universe is hostile to life. The stars that create the planets are also the ones that destroy them. Given all of this cosmic violence, all of this stellar danger, the fact that we're here at all seems almost miraculous. Let me tell you why our solar system is so fortunate. Our solar system formed about 4.6 billion years ago from a stellar nursery. That nursery was enriched with heavy elements from multiple supernova explosions. One of those ancient supernova might have even provided the shock wave that triggered the collapse that became our solar system. The sun formed at the center. Around it, a disk of gas and dust began to spin. In this disk, our planets formed. Mercury, Venus, Earth, Mars formed quickly, within a few million years. These inner planets are rocky, composed primarily of the materials that could withstand the heat near the young sun. Further out, Jupiter and Saturn formed. These are gas giants. They contain vast amounts of hydrogen and helium, captured from the early solar system's disk. But here's what's mind-blowing. The solar system we see today is not the original solar system. The planets have moved significantly. When Jupiter and Saturn formed, they were probably much closer to the Sun than they are now. According to something called the Grand Tack hypothesis, proposed by Clintus Siganes and colleagues in 2005, Jupiter migrated inward, almost reaching Mars's orbit. This migration would have been catastrophic for the inner solar system. It would have scattered the planets, caused collisions, and potentially destroyed the early Earth. But then something incredible happened. Saturn's gravity caught Jupiter. Jupiter and Saturn entered into an orbital resonance, and then they migrated outward together. This migration scattered planetesimals throughout the solar system. Some of this scattered material reached Earth. This is called the Late Heavy Bombardment, and it occurred about 4.1 billion years ago. The Grand Tack hypothesis was developed through computer simulations run by teams at the Nice Observatory in France, led by scientists like Clintus Siganes and Alessandro Morbidelli. These simulations showed that the only way to reproduce the current configuration of the solar system, with the observed distribution of asteroids, was if Jupiter migrated inward and then outward. This model explained something that had puzzled astronomers for decades. Why do we have such a clear dividing line in the solar system between terrestrial planets and gas giants? Why is there a gap between Mars and Jupiter filled with asteroids? The grand tech answered it, because Jupiter migrated through that region, scattering everything in its path. Here's why this matters to you. The water in your body might have come from asteroids that were scattered during the grand tech. The organic compounds that formed the basis of life on Earth might have been delivered by meteorites that came from the outer solar system. Jupiter's migration created instability, but that instability also brought the chemical ingredients necessary for life to Earth. Without Jupiter's migration, without that planetary chaos, life might not exist on Earth. Think of it like this. Jupiter is like a cosmic gardener. Its gravity reshapes the solar system. It creates chaos. But in the process, it plants the seeds for life. There's something else incredible. Jupiter's gravity has been protecting us the entire time. Jupiter is by far the most massive planet in the solar system. As it orbits, its gravity acts like a shield. Asteroids and comets that would otherwise collide with Earth are often redirected by Jupiter's gravity. Some of these objects collide with Jupiter instead. This happened spectacularly in 1994, when a comet called Shoemaker-Levy 9 broke apart and crashed into Jupiter. Astronomers observed the impacts. Each impact released energy equivalent to thousands of nuclear weapons. If a comet that size had hit Earth instead, it would have been catastrophic. But Jupiter intercepts these objects. Jupiter is like a guardian, using its massive gravity to protect the inner planets. Let me summarize what's happened to create you. A star exploded. That explosion seeded space with heavy elements. A new star formed, our Sun. Planets formed around it. Those planets migrated, creating chemical chaos. But this chaos brought the ingredients for life. Asteroids bombarded Earth, bringing water and organic compounds. Our magnetic field formed, protecting us from the solar wind. Jupiter protected us from impacts. Every step of this process was precarious. At any point, things could have gone differently. You could not exist. This planet could be a sterile rock. Instead, life emerged. But here's something profound. We're not at the end of the story. The Sun is middle-aged. It has another 5 billion years left. In that time, the solar system will continue to change. The planets will continue to move. The Sun will continue to brighten, heating Earth progressively more. And eventually, the Sun will die. This might be the most important thing you hear all day, because it's about your future, about humanity's future, about Earth's future. I'm going to tell you exactly what's going to happen to our planet. The Sun is currently in the main sequence phase of its life. It's burning hydrogen into helium. It will continue doing this for about another 5 billion years. But during this time, the Sun is getting gradually brighter. It's brightening at a rate of about 10% per billion years. This means Earth is getting warmer. Gradually, over billions of years, the planet is becoming less habitable for complex life. In about 1 to 2 billion years, the average temperature on Earth will rise enough that photosynthesis will become impossible for plants. The oceans will evaporate. The planet will become a hellscape of heat and drought. But that's not the catastrophic part. In about 5 billion years, the Sun will exhaust its hydrogen. When this happens, the hydrogen fusion in the Sun's core stops. Without the outward pressure from fusion, gravity wins. The core collapses. This collapse heats the core to such extreme temperatures that hydrogen in a shell around the core ignites. The Sun begins fusing hydrogen in a shell. This shell fusion is unstable. It causes the Sun's outer layers to expand violently. The Sun becomes a red giant. Its radius expands to about 250 times its current size. This means the Sun will expand far beyond Earth's current orbit. Earth will be engulfed. The planet will be consumed by the Sun, not destroyed instantly. The Sun's outer atmosphere is less dense than you might think. Earth will actually orbit within the Sun's atmosphere for a period of time before friction from the Sun's gases drags it into the denser inner regions and destroys it completely. This process has been modeled in detail by astrophysicists like Ich Baraf, and colleagues at the University of Exeter. They've created sophisticated models of stellar evolution that show exactly what happens when the sun becomes a red giant. They've calculated how much the sun will expand, how hot it will become, what will happen to the planets. Their models show that Earth's fate is sealed. The planet will not survive the sun's red giant phase. Some models suggest that Earth's orbit might expand slightly due to mass loss from the sun. As the sun sheds its outer layers, it loses mass, and its gravity weakens. Planets in orbit around a less massive object are pushed outward, so Earth might escape being engulfed. Instead, it might become a cold, dead, airless cinder orbiting a white dwarf. Either way, the result is the same. Earth will be rendered completely uninhabitable. Now, let me ask you something. Does this depress you? Does it feel hopeless? Does it seem like all civilization, all progress, all love and joy and achievement is ultimately meaningless because it will all be destroyed? If so, I understand. But I want to suggest a different way of thinking about it. We have 5 billion years. That is an incomprehensibly long time. Humans have existed for 300,000 years. In 5 billion years, humanity will have 16,067 times longer to develop, to grow, to progress than we've had so far. What will humanity look like in 1,000,000 years? In 1 billion years? We can't even imagine it. The changes will be so profound that our descendants might be unrecognizable to us. And they'll have plenty of time. 5 billion years to leave Earth, to spread to other planets, to other stars, to create civilizations and worlds and experiences we can't conceive of, to make meaning and create beauty and build lives of profound significance. The fact that Earth will eventually be destroyed is not depressing. It's liberating. It's a reminder that everything we do matters, because the time is finite, because we have a window of opportunity, because the universe is calling us to become more than we are. But here's something else. The end of Earth doesn't mean the end of life. Life might spread. Humans might leave Earth. Other intelligent species might do the same on other worlds. The universe might be filled with civilizations, each preserving knowledge, beauty, and consciousness even as their home stars die. And that raises a profound question. Are we alone? When you look at the night sky, you're looking at billions of stars and billions of planets. The statistics suggest that life should be common, but we haven't detected it. Not yet. Is anyone out there? Let me give you the numbers. There are an estimated 100 billion galaxies in the observable universe. Each galaxy contains an average of 100 billion stars. Each star, statistically, has at least one planet. That's 10 billion planets. 10 septillion planets. By any reasonable estimate, intelligent life should exist on millions of worlds. Billions of worlds. Yet we detect nothing. No radio signals. No astroengineering projects. No signs of technological civilizations. This is the Fermi paradox. And it's unsettling. There are many proposed solutions. The most sobering is called the Great Filter. The Great Filter hypothesis suggests that somewhere along the path from non-life to galactic civilization, there's a step so difficult, so improbable, that it almost never happens. This filter could be early in the process. Maybe life is incredibly rare. Or it could be late. Maybe civilizations almost always destroy themselves. If the filter is ahead of us, we might be among the first intelligent species in the galaxy. Unique. Alone. If the filter is behind us, we should expect to find intelligent life everywhere. The fact that we don't suggest the filter is ahead of us. Carl Sagan, the legendary astronomer and science communicator, spent decades thinking about this problem. In his book, Cosmos, published in 1980, Sagan explored the possibilities. He noted that every technological civilization we know of, which is to say, our own, faces a critical test. Can you develop nuclear weapons without destroying yourselves? We've barely passed that test. Twice during the Cold War, we came within minutes of nuclear war. Accidental launches, false alarms, miscommunications. We survived by luck. Maybe most civilizations don't. Maybe they develop technology, and then they destroy themselves. Maybe that's the great filter. Maybe that's why the universe is silent. But Sagan also pointed out something hopeful. The fact that we're here, thinking about this, asking these questions, means that we've already passed some of the filters. We've emerged as an intelligent species. We've survived long enough to develop technology. We're at a point where we're aware of the risks and thinking seriously about avoiding them. Sagan believed we might be among the first. He believed this placed a profound responsibility on us to survive, to preserve civilization, to eventually reach out to the cosmos. Let me tell you about one of the most profound attempts to contact extraterrestrial intelligence, the Arecibo message. In 1974, astronomers used the Arecibo Radio Observatory to broadcast a message toward the globular star cluster M13, about 25,000 light-years away. The message was encoded in binary and contained information about humanity, our position, our chemistry, our DNA structure, even a picture of the Arecibo Observatory itself. It was a cosmic hello, a way of saying, we exist, we're intelligent, we're here. Of course, the message won't reach M13 for 25,000 years. And any reply would take another 25,000 years to reach us. But the point was profound. We reached out. We said, is anybody listening? And that's what you're doing right now, in a way. By watching this, by learning about the cosmos, by asking questions about the universe, you're participating in humanity's ongoing conversation with itself about our place in existence. You're part of the search for meaning, because that's really what all of this is about. It's not just about discovering if aliens exist. It's about understanding who we are, where we came from, why we're here. The stars tell us these answers. Every element in your body was forged in a star. Every atom of consciousness you have was created in stellar furnaces. You are intimately connected to the cosmos. You are not separate from it. You are part of it, a conscious expression of it. This realization, this understanding that you're made of stars, that your consciousness is a product of stellar evolution, that you're literally composed of supernova shrapnel, this changes how you see yourself in the universe. You're not insignificant. You're not a random accident. You're a focal point. You're the universe becoming conscious of itself. You're stardust that learned to think. There's a moment in your life when understanding the cosmos shifts from being intellectual to being existential, when it stops being information and becomes identity. I think you might be having that moment right now. Let's trace your atoms backward through time. The calcium in your bones came from a star. That star lived for billions of years. Then it exploded in a supernova. The calcium was scattered into space. It drifted for millions of years. It collided with a gas cloud. It was incorporated into a new solar system. On a rocky planet orbiting that star, chemical reactions happened. Organic compounds formed. They organized into self-replicating systems. Life emerged. Evolution occurred. Fish crawled onto land. Dinosaurs walked the earth. Mammals emerged. Primates developed. Humans evolved. Consciousness emerged. And now, that calcium from that ancient supernova is part of your skeleton. It's holding you up. It's making you stand. The atoms that make you possible are atoms that have been recycled through stars, through planets, through millions of years of biological evolution. You are not separate from the universe. You are the universe's way of experiencing itself. Think about what this means. Consciousness itself is a cosmic phenomenon. It's a product of stellar evolution. The intelligence required to understand the universe was created by the universe. We are the means by which the cosmos knows itself. This isn't poetry. This is physics. This is chemistry. This is biology. The atoms, the elements, The molecules that make up your brain, that encode your thoughts, that create your consciousness, they all came from stars. They all came from the cosmos. The universe created the instrument that allows it to study itself. You are that instrument. The astronomer Carl Sagan expressed this beautifully. He said, "The cosmos is within us. We are made of star stuff. We are a way for the cosmos to know itself." This wasn't just poetic language. Sagan was also a scientist. He was expressing a profound truth that emerges from physics and chemistry and biology. When you study the cosmos, you're not studying something external to you. You're studying your own origin. You're studying the process that created you. You're studying yourself. Let me make this even more concrete. The iron in your blood came from a supernova. That iron has been on Earth for 4.6 billion years. It's been through the Earth's interior, was brought to the surface by plate tectonics, was incorporated into plants, was eaten by animals, was incorporated into animals, and eventually, through a long chain of evolution, was incorporated into your body. That iron atom has lived in dinosaurs. It's lived in mammals. It's lived in humans for thousands of years before arriving in you. Your blood is a river of recycled atoms flowing from the stars through time and life and consciousness into you. Every breath you take contains atoms that have been recycled through countless organisms, countless ecosystems, countless stars. You're not a separate entity from the universe. You're a temporary organization of it. You're a pattern that the universe has created. And when you die, that pattern will dissolve, and the atoms will go on to other patterns, other organizations, other forms. This should make you feel something profound. Not sadness, not insignificance, but humility and awe and a sense of connection. Every person you meet is made of stardust. Every person you encounter is the universe experiencing itself through a different pattern. Every organism you see, from the smallest bacterium to the largest whale, is a temporary organization of cosmic material, briefly conscious of its own existence. And that's the ultimate significance. Not that we'll live forever, but that we get to exist at all, that we get to be conscious, that we get to ask questions and seek understanding, that we get to create meaning. Think about what you do with your consciousness, what you create, what you build, what you love, what you share. Every act of creation, every expression of love, every moment of understanding, these are cosmic acts. They're the universe creating, the universe loving, the universe understanding itself. You are not insignificant. You are essential. The universe went to extraordinary trouble to create you. You're not an accident. You're an achievement of stellar evolution, of planetary formation, of billions of years of biological development. Your consciousness is literally made of stardust. And that stardust cares about things. It creates art. It seeks beauty. It loves. It dreams. It asks questions about the cosmos. That's extraordinary. That's profound. That's you. But here's the thing. This understanding should also inspire action. Knowing that you're made of stardust, knowing that the atoms in your body have a cosmic history, knowing that consciousness itself is a rare and precious emergence of the universe. This should change how you live. It should make you want to preserve consciousness, to protect life, to spread understanding, to create beauty, to reach toward the stars. We stand at a unique moment in cosmic history. For the first time in the history of this planet, an intelligent species has emerged that understands the cosmos, that understands its own origin, that understands the stars. What we do with this knowledge will determine everything about humanity's future. Here's something that should inspire you. We are in the early stages of becoming a spacefaring civilization. We've sent robots to Mars. We've landed humans on the moon. We've sent probes to the outer planets. We're planning crewed missions to Mars within decades. We're designing space stations to orbit other planets. We're imagining ways to terraform worlds. Humanity is spreading beyond Earth. And this is just the beginning. Think about it. In the next 100 years, humans might establish permanent colonies on Mars. We might mine asteroids. We might build space habitats. We might send probes to nearby stars. In the next 1,000 years, we might have civilizations spanning multiple planets, multiple star systems. We might have seeded the galaxy with human outposts. In the next 1,000,000 years, we might be unrecognizable. We might have merged with artificial intelligence. We might have edited our own genetics. We might have spread to hundreds of star systems. We might have become something that current humans wouldn't classify as human anymore. Here's what will blow your mind. If humanity survives and continues to expand, we might eventually prevent Earth's destruction. We might develop technologies that allow us to move planets. We might engineer ways to extend the sun's life. It sounds like science fiction, but it's within the realm of physical possibility. If you have a civilization that spans multiple star systems, if you have access to the energy and resources of stars, you might be able to accomplish things that seem impossible now. Or we might not prevent Earth's destruction. We might accept it. We might let Earth be consumed by the sun, knowing that the data of human civilization, everything humanity has created and learned, has been preserved somewhere else, on other worlds, in the consciousness of whatever humanity becomes. Carl Sagan spent his life thinking about humanity's future. He was cautiously optimistic. He believed that if we could avoid self-destruction, if we could make it past the Great Filter, we would have billions of years to develop. He imagined vast interstellar civilizations preserving knowledge, spreading consciousness, creating beauty on scales we can't imagine. But Sagan was also realistic. He knew that the path to galactic civilization was fraught with danger. He knew that civilizations could destroy themselves. He knew that we faced existential risks. He believed our responsibility was to become wise enough to survive, to develop not just technology, but wisdom, to learn to manage our power responsibly. Right now, as you watch this, humanity stands at a crossroads. We have the technology to destroy ourselves many times over. We also have the technology to leave Earth. We have the knowledge to understand the cosmos. We have the capacity to spread consciousness to the stars. What we do in the next few decades will determine which path we take. Will we become a spacefaring civilization that spreads intelligence throughout the galaxy? Or will we destroy ourselves and remain a brief, extinct note in cosmic history? This is your generation's choice, your responsibility, your opportunity. And here's why this matters. The cosmic story isn't over. The universe is still creating. Stars are still being born. Planets are still forming. Life is still emerging on thousands of worlds. And we are part of that story. If we preserve ourselves, if we spread beyond Earth, if we continue to create and innovate and understand, then consciousness will continue to evolve. The universe will continue to know itself. The cosmos will continue to create. But if we fail, if we destroy ourselves, then the universe loses a voice. Consciousness that took billions of years to create will wink out. This world, this story will end. That's your significance. That's why you matter. You're not insignificant. You're a carrier of consciousness. You're part of a cosmic process that's been unfolding for billions of years. You're a temporary focal point of the universe's self-awareness. What you do matters. How you treat consciousness, your own and others, matters. Whether you preserve knowledge, create beauty, spread understanding, these things matter, because they're contributions to the ongoing story of the cosmos. You are a star. You contain the energy of stars. You're made of stardust. You're an expression of stellar evolution. And you have the responsibility and privilege of being conscious of this fact. We're approaching the end of this journey through the stars, but I want to offer you one final thought, one that ties everything together, one that might change how you experience every moment of your life going forward. I want to end with something that might seem simple, but it contains everything we've discussed. The next time you look up at the night sky, I want you to really see it, not with your eyes, with your understanding, with your whole being. When you look at the stars, you're not looking at distant objects. You're looking at your family. You're looking at your ancestors. Those stars created the atoms that make you. Some of those stars have already died. Their deaths seeded the galaxy with the elements necessary for your existence. You are looking at the cosmos that made you. You are looking at yourself, reflected across billions of years, billions of light years. And here's what's profoundly important. The light you see from those stars, in many cases, left those stars before life existed on Earth. Some of that starlight has been traveling for longer than humans have existed. When you see the light from a star, you're seeing into the past. You're seeing what the universe was like billions of years ago. That light is a time machine. It's a message from the ancient universe. It's telling you about the processes that created you. Think about this. Every object you see in the night sky is still alive. Every star is still fusing hydrogen. Every planet is still orbiting. Every cosmic process is still happening. You're not looking at static objects. You're looking at a dynamic living universe. And you're part of it, right now, this instant. Your atoms are part of the same universe that created the stars. Your consciousness is the same phenomenon as stellar consciousness in a different form. You and the cosmos are one, temporarily separated into parts, but fundamentally unified. Carl Sagan, in his last book, The Varieties of Scientific Experience, wrote something that captures this. A knowledge of where we have been and an understanding of where we are is the beginning of how to proceed. Sagan spent his life trying to convey this perspective, that understanding our cosmic origin, understanding that we're made of stardust, that consciousness is a cosmic phenomenon, that we're part of a vast, ancient universe. This understanding should inspire awe, humility, and responsibility. Awe, because the universe is incomprehensibly vast and beautiful and creative. Humility, because we are small, temporary expressions of it. Responsibility, because consciousness is rare and precious, and we have the ability to preserve it, expand it, understand it more deeply. Let me give you a concrete practice. I want you to commit to looking up at the night sky once a month, not with your phone, not trying to identify constellations, just looking, just letting yourself feel the scale, just remembering that you're made of that light. In that moment, when you feel insignificant and awestruck, hold both feelings at once. Hold the feeling that you're small, and also the feeling that you're precious, that you're temporary, and also eternal in the sense that your atoms will continue to exist and be part of the cosmos forever, that you're one person among billions, and also unique, that the atoms that make you have been recycled through millions of organisms, and will be recycled through millions more after you die. You're a wave in the ocean of existence, temporary, beautiful, essential. I want to ask you to do something right now. I want you to pause this video. I want you to put your hand on your chest. I want you to feel your heartbeat. That's the rhythm of the universe. That's the star inside you, burning, keeping you alive. Every heartbeat is a small explosion of energy, derived ultimately from fusion, derived ultimately from the sun, derived ultimately from the stars. Your body is a star. You are stardust that has learned to beat with a heart, to think, to love, to wonder. That's not insignificant. That's the most significant thing in existence. Let me tell you what I hope this journey through the stars has done to you. I hope it's given you a sense of belonging, not to a nation, not to a political party, not to an ideology, but to the cosmos, to the universe, to the process that created you. I hope it's made you feel connected to every other human being on this planet, because you're all made of stardust. You're all temporary organizations of cosmic material. You're all precious expressions of a universe billions of years old. And I hope it's inspired you, not just to look up at the stars, but to live a life that's worthy of that cosmic origin, to create meaning, to preserve consciousness, to reach toward understanding, to treat other conscious beings with reverence, to build something beautiful. Because here's the ultimate message: the universe is not indifferent to you. The universe created you. You are the cosmos becoming conscious. You are the point at which the universe knows itself. What you do matters. How you live matters. The beauty you create, the love you express, the knowledge you preserve, these things matter because they're cosmic acts. They're the universe creating, loving, understanding itself through you. Before we wrap up, I want to thank you for taking this journey with me, for staying with me through these mind-bending concepts, for opening yourself to a cosmic perspective on your own existence. I want to ask you to do 3 things. First, comment below and tell me which moment in this video was most mind-blowing for you. Which concept changed your perspective the most? I read every single comment, and I want to know what's resonating with you. Second, share this video. Send it to someone you care about. Because this perspective, this understanding of cosmic significance, is something everyone deserves to feel. This is knowledge that can change lives. It can inspire people to live differently, to think differently, to see themselves and each other differently. Third, subscribe, because we're not done. There's so much more to explore about the cosmos, about consciousness, about our place in the universe. I'm creating more videos that will take you deeper into these ideas. Don't miss them. And here's my parting thought. Every person who ever looked up at the night sky and wondered about the cosmos was participating in something sacred. Whether they believed in religion or not, whether they called it spirituality or science, they were asking the deepest questions. Where did I come from? Why am I here? What's my place in existence? The stars answer these questions. Not with certainty, but with truth. You came from the stars. Your atoms are stellar atoms. Your consciousness is a product of stellar evolution. Your place is here, on this small planet, temporarily organized into a human being, capable of wonder and love and creation. That's your cosmic significance. That's why you matter. Billions of years from now, when the sun has died, when Earth has been consumed, when perhaps humanity has spread to 1,000 star systems, the atoms that are currently making up your body will be part of something else. Some of your atoms might be in the stars of a distant world. Some might be in the consciousness of future beings we can't imagine. Some might be part of the structure of a civilization so advanced that we can barely conceive of it. But the cosmic significance of what you are right now, in this moment, that will never diminish. You are a focal point of the universe's self-awareness. You are stardust that became conscious. You are the cosmos looking at itself. And that is everything. Thank you for letting me share this journey with you. Thank you for caring about the cosmos. Thank you for being part of the universe's ongoing story. Thank you for being conscious. Thank you for being here. Look up at the night sky. Remember where you came from. Remember what you are. And then look at the people around you. And remember that they're made of stardust too. That they're part of the same cosmic process as you. That they matter. That consciousness matters. Create meaning. Preserve knowledge. Spread understanding. Reach toward the stars. Because that's what stardust does when it learns to think. If you haven't subscribed yet, please do. Hit that like button. Comment where you're watching from and what country you're in. I want to hear from you. I want to know that this cosmic perspective has reached people around the world. That people are looking up at the same stars, feeling the same cosmic connection, remembering the same cosmic origin. We're all connected by atoms, by light, by the fundamental processes of the universe. You're not alone. You've never been alone. You're part of something infinite, eternal, beautiful. Thank you for watching. Thank you for caring about the cosmos. Thank you for being conscious. Until next time, keep looking up.